Good day, everyone. We're reviewing Wetzel's Limnology textbook. This is edition number 4, and we are focusing on chapter 12, which deals with salinity and ionic composition of inland waters. And today we'll just focus on the summary of that chapter. So let's get started. In inland waters, total salinity, the mass of dissolved inorganic solids, is usually dominated by 4 major cations: calcium, magnesium, sodium, and potassium, and the major anions: bicarbonates, carbonates, sulfate, and chloride. Inland waters range in salinity from near 0 to over 400 grams per kilogram. The delineation of fresh versus saline waters is generally accepted as 3 grams per kilogram. Saline lakes, salinity greater than 3 grams per kilogram, are present on every continent on Earth, and their ion composition is a result of the interplay of hydrology, evaporation, and geology. The salinity of inland waters is a composite of ionic contribution from rock and soil weathering, atmospheric precipitation and deposition, and the balance between evaporation and precipitation. The salinity of global river waters has an average concentration of about 128 milligrams per liter, but varies among continents and with the lithology of the land masses and drainage basins. Concentration of major ions of many surface waters of the world exists in the proportion of calcium greater than magnesium, sodium, potassium, bicarbonate, carbonate, sulfate, and chloride. In soft waters and in surface waters of coastal region, sodium and chloride often occur in greater proportions. The supply of ions for rocks and soil is controlled by the processes of chemical weathering, solution and oxidation reduction, and the formation of organic complexes. The depth and mode of water percolation through soil will influence the loading of ions to natural waters. Concentration of the cations, magnesium, sodium, and potassium, as well as the major anions, chloride, are relatively conservative and undergo only minor spatial and temporal fluctuation within a lake from biotic utilization or biotically mediated environmental changes. Calcium inorganic carbon and sulfate are dynamic, and concentrations of these ions are influenced strongly by microbial metabolism. Proportional concentration of major cations and the ratio of monovalent to divalent cations can influence the metabolism of many organisms, particularly certain algae and submerged macrophytes. Therefore, processes that influence the availability of some cations disproportionately to others, organic complexes of calcium or biologically induced decalcification of the epithelium, can indirectly affect seasonal population succession and productivity. The relative low salinity of freshwaters has influenced the distribution of biota and their long evolutionary history of physiological adaptation for osmotic and ionic regulation in an extremely hypotonic environment. Although some groups of microbes and algae are relatively homoosmotic and can tolerate only a narrow range of salinity, many lower flora and fauna are uralian, that is adaptable to a wide range of salinity. Most higher-order freshwater animals originated from the sea or from land and adapted to freshwater syngonally. In comparison to marine forms, nearly all of these organisms have reduced osmotic pressures of body fluids and have developed efficient mechanisms for the active uptake of ions and renal mechanism for ion retention. Inland water salinity is predicted to increase in the future due to climate change, human activities, and heightened demands for freshwater resources. Salt loading to freshwaters is a byproduct of resource extraction, agricultural intensification, industrialization, and urbanization. Salinity will rise due to increased evaporation, drought, sea level rise, and freshwater diversion. So this summarizes the summary of the chapter 12 that deals with salinity and ionic composition of inland waters. And I will see you tomorrow, and tomorrow we will start chapter 13 that focuses on the inorganic carbon complex. Thank you, and see you tomorrow. Bye.